Hi, my name is Ting Da Jie. I would like to introduce my leader, Holly Ying, and two members who are Yap Wan Yi and Lau Seng Jie. Today, I would like to present about our project, IoT-based smart agriculture. Internet of Things-based smart agriculture project is to develop an automation system that includes an irrigation system and lighting system. Multiple features including wireless monitoring plants, adaptable varied components and sensors, easy to installations and user friendliness will be incorporated into the automation system when it is developed. The irrigation system is designed to automatically water crops based on their specific needs, which can be determined using data from moisture sensor, weather forecast, and other factors. This ensures that crops receive the optimal amount of water, which can help to reduce water waste and improve crops growth. Meanwhile, preventing automatic overwatering or underwaterings are essential tasks for irrigation system. On the other hand, the lighting system is called the artificial lighting to supplement natural light. This involves the use of LED lights that emits blue and red wavelength of light, which are known to improve for plant growth as well. The blue light promotes vegetative growth, while the red light simulates flowering and fruiting. By controlling the timing and intensity of these lights, farmers can optimize the growth and development of their crops, leading to higher yields and improve the quality.
My name is Lau Seng Jie. Now I want to explain about the problem statement in our project. So the first one is the laborious and time-consuming to take care of plant. The process of taking a good care of indoor plant is considered laborious and time-consuming, especially for people living a hustle urban lifestyle. Without proper care, a living plant can wither within a week. With the trend of mobile communication technology, taking care of plant could be effortless and time-saving, yet ensuring healthy growth of the plant. The second is poor lighting conditions may affect crop growth. Indoor gardening is described as creating artificial growing environment for plant. There are several conditions where growing plant in natural environment is implicable. The reasons are due to weather or temperature conditions, species, and size of plant. A growing plant indoor with the help of technology will maximize the control over the environment variable such as temperature, light, and humidity, which ultimately creating the most suitable cultivating or growing environment. The last one is growing plant in natural condition is not applicable. Light is one of the primary sources of energy for photosynthesis, which is the process by which plants convert light energy into chemical energy to fuel their growth. When plants do not receive enough light, the ability to carry out photosynthesis is reduced, which can result in slower growth and development, lower yields, and reduced nutritional quality. This is because without adequate light, plants may not be able to produce enough carbohydrate and other essential components necessary for growth.
Hi everyone, my name is Holly. I would like to share with you the objectives that we have been working on in this IoT-based smart agriculture system. Growing up, I saw how difficult it was for my mom to take care of our small vegetable and flower garden. She had to wake up early every morning to water and tend to the plant, and sometimes she still struggled to keep them healthy. However, farming and gardening is my mom's hobby. I cannot stop her, but I think I can help her. This experience stuck with me and it led me to start thinking about how technology could help and make farming and gardening easier and more efficient. And that's how we came up with this idea. Our objective is to develop an IoT-based smart agriculture system that incorporate automation and real-time monitoring in order to help farmer and gardener like my mom who struggle with the laborious and time-consuming task of taking care of plants. Next, we also want to design an IoT-based smart agriculture system that automatically adjust the lighting condition based on the specific needs of different crops and promoting optimal growth and development. Lastly, our objective is to study and implement sensor and adaptive components that can detect change in environment conditions and adjust the irrigation and lighting accordingly, optimizing plant growth and minimizing the waste. We believe that by using the technology to make farming and gardening more efficient and sustainable, we can contribute to a healthier planet and a better future.
My name is Yapwan Yi. Now, I would like to explain the solution of our project. We have used some sensors such as adjustable soil moisture sensor and light dependent resistor (LDR) sensor in our project. Adjustable soil moisture sensor is a device that measures the water content in soil and can be calibrated to detect specific moisture levels. In our project, we use it to automatically water plants to solve watering problems. LDR sensor is a device that detects changes in light intensity and adjusts its resistance accordingly. In our project, we use it to ensure that plants receive the optimal wavelengths needed to carry out photosynthesis at night or in low light conditions. Besides, we also use some software such as ThinkSpeak and Arduino IDE to implement our IoT applications. ThinkSpeak is an IoT platform that enables users to collect, analyze, and visualize sensor data from various devices in real time. In our project, we use it to display LDR value, display soil moisture, display water pump watering times. Arduino IDE is a cross-platform integrated development environment that enables users to write, compile, and upload code to Arduino microcontroller boards. In our project, we use it to connect to Arduino hardware for uploading programs in our IoT project. The explanation of sensors and softwares I presented just now was a brief introduction to the next video. In the next video, video log 2, we will give a clear and concise presentation of the hardware and software that we will use to implement our idea. That's all from us. Thank you.
Hi, my name is Sindaje, and today I would like to present about all of the hardware that we use in IoT Smart Agriculture. By using Arduino UNO R3 as baseboard, the ATmega328 AVR microprocessor is detachable and packaged in dual inline package, stand for DIP, which is what makes the Arduino UNO R3 microcontroller board possible. It features 20 pins for digital inputs and outputs, of which 6 be used PWM output and 6 can be used as analog input. The user-friendly Arduino computer program can be used to upload programs directly into the device. ESP8266 Wi-Fi modules is able to interface with Internet of Things platforms and the cloud by utilizing API key and HTTP protocol. As a result, we use to monitor and manage the private sensor data which are uploaded into ThinkSpeak to do the data virtualization. A software device for creating temporary prototypes with electronics and for testing circuit design is known as breadboard. All of the components or sensors of the smart agriculture, such as LDR sensor, LED, moisture sensor, and water pump, are connected to the breadboard so they can receive electricity from it and be controlled by the Arduino UNO. In our project, we use the jumper wire got two types. One is the female to males and male to males. And male to males, we use to connect two ports on the breadboard, and the jumper wire we use to build the connection circuit between the breadboard and the various sensors. In irrigation system, sensors that measure or estimate the amount of water in the soil, known as soil moisture sensor. Stationary sensors are installed in the field at the predefined depths and positions, whereas portable soil moisture probes are able to monitor the moisture contents of the soil in variety of environments. There is a water pump that can be used to water the plants. The water pump is in the automated watering system will be regulated by the soil moisture sensor. In lighting system, LDR sensors also stand for light dependence resistor. They are frequently used in situations where it's necessary to determine the presence of the light as well as the level of the light intensity. They are also have red and blue LED will be utilized for the construction of the automation lighting system that will be controlled by the LDR sensor.
My name is Lao Senjie. Now I want to explain about we use what kind of software to implement our IoT applications. ThinkSpeed is a cloud-based Internet of Things IoT platform that enables programmers to collect, analyze, and act on data from IoT devices. It has several properties that make it practical tool for creating IoT applications. For example, ThinkSpeed offers a user-friendly API for gathering data from a variety of IoT devices, such as sensor, actuators, and other connected devices. Additionally, ThinkSpeed offers a number of integrated visualization tools that let users design unique dashboards and visualization to track and examine their IoT data. ThinkSpeed can be easily integrated with other IoT platforms such as Arduino and Raspberry Pi. As a result, we will use the ThinkSpeed to display LDR sensor value, soil moisture, and water pump watering times. The last one is Arduino IDE. Arduino IDE is an open source software. It contains a text editor for writing code, a message area, a text console, a toolbar with the buttons for common functions, and a series of menus. It connects to the Arduino hardware for uploading programs and communicate with each other. This Arduino IDE is a subset of C and C++, so both languages are supported to write, edit, and compile. For instance, users can code, compile, save, and upload to a specific microcontroller device by simply searching for and installing the open source library package for that microcontroller from the library management tools in the program. Developer will use the Arduino IDE to connect to the Arduino hardware for uploading program in our IoT project.
Hi, my name is Indaje, and today I would like to present about how our Arduino circuit look like. First of all, I want to present how I configure the Wi-Fi modules. So this the Wi-Fi module look like, and this one, the black color, will be connected to the ground, and this red and orange color will together connect to the 3.3 volts, and the yellow color ones and the blue color ones is mean the RX and TX to connect to the pin 2 and pin 3. And this is our cord, and the RX is 2 and TX is 3 to let the EXP8266 to connected to with the Arduino. And second, I want to present about the configuration of the LDR sensor. And for the LDR sensor, I declare the LDR pin as A0. It means the other side is A0 and the other side is the 5 volts, which means the A0 will can get the data from the LDR into the Arduino. The A0, the yellow color one, into here, then connect to the LDR, and the orange color is connect to the 5 volt here. And next, the LDR pin is control the LED pins, means the output is 13. And the 13th output will control by the red wire. The red wire will connect to here, the breadboard positive there, and pass all the current in the straight line, the vertical red line, and to control the LED. And when the LDR sensor is detect brightness, the LED will automatically switch off. The next system is irrigation system, and the sensor is called the moisture sensor. The moisture sensor is send the data in the A2, and which means I will declare the moisture sensor as A2 to get the moisture sensor value. And the moisture sensor value will pass out and control the water pump and pin 7. And pin 7 is here. This yellow is purple color one. Then the purple color ones will connect to this LED, and this LED is considered the water pump for convenient use. When the soil is wet, it will detect the percentage is more than 80, then it will become shift off the currents. That's all for my lot 3 for the configuration of Arduino board and the programming part.
Good day everyone, I'm Holling. Today I'm going to share with you about our IoT-based smart agriculture project, that how I use ThinkSpeed to visualize the data in this video log form. In the first step, we need to create a ThinkSpeed channel. We log in into our ThinkSpeed account and click on the new channel. Next, enter a name and description for the channel and add field with appropriate name that correspond to the data we'll be collecting. In this case, we are using LDR sensor and a soil moisture sensor, so we will name our field as LDR brightness and moisture percentage, respectively. And finally, I click on the Save Channel to create the channel. After we create the channel, click on the API key tabs of my ThinkSpeed channel, and then click on the Generate New Write API key to get the API key. This API key is a Unicode identifier that allows our smart agriculture system to update ThinkSpeed channel with data. I copy this API key to my clipboard first, and then open the Arduino IDE, open our file. We declare the variable for our ESP8266 module, including the SSID and password for the Wi-Fi network, and paste the ThinkSpeed API key into our code. I also define the TX and RX of our ESP8266 with Arduino pin 2 and 3. To connect the Wi-Fi and ThinkSpeed, we set up the ESP8266 module encoding using the ESP8266 Wi-Fi library. We send command which make connection between the Wi-Fi module and the internet. We also use the function like ESP8266.println and find function to check the response code to ensure the connection success status. To update my ThinkSpeed channel with the data from our smart agriculture system, I use the update API request and pass the LDR status and the moisture percentage parameter. After all of the steps, we can investigate the data visualization by checking the connection successfully with the Wi-Fi and ThinkSpeed. They are okay, which means that the connection is successful. And in the output, we see the chart that represents our data in the Lightning System data visualization. The light brightness is less than or equals to 250, that means in the darkness place, then the LED light will be switched on automatically. And the light brightness value is more than 250, that means in the brightness place, then the LED light will be switched off automatically. And the other data, soil moisture value in irrigation system data visualization. Soil moisture value is less than or equals to 80%, That means soil is in dry condition. Then the water pump will be switched on automatically and watering the plant. And soil moisture value is more than 80%. That means soil in the wet condition. Then the water pump will be switched off automatically. In conclusion, using ThinkSpeed allows us to easily update and visualize the data from our smart agriculture system. Thank you for your attention, and now we will proceed to the next video log 5. Good morning, I'm Holly. I'm the group leader. Our project is IoT-based smart agriculture. This is my group member.
I am Lao Senjie.
I am Ding Da Jie.
I'm Yap Wan Yi.
Okay, so our system is lightning system. I will introduce the lightning system first in our smart agriculture. So this is the LDR sensor. This is to detect the lightning brightness. So if I close it, it means it will be the darkness phase. Then the LED will be triggered. Then the LED is the blue wavelength and the red wavelength. It means it can help our flower to produce the photosynthesis. And the LDR sensor will be uploaded into the ThinkSpeed virtualization. Then if just now is 428 and because the darkness, it will become the 121. Then so the LED will be triggered. Yeah. So in our project, smart agriculture, the second system is irrigation system. So the irrigation system need the moisture sensor, and this is the moisture sensor. And the LED light means the water pump. When the LED is lightning, it means the water pump doesn't trigger. If I take it out the moisture sensor, it means the water pump will be triggered and it will watering the plants. When the moisture sensor is put on the wet soil, it means the LED will be close it out with switch off, and the water pump will be not to watering the plant. And this is the moisture sensor visualizations, and the percentage stand for the moisture soil. When the moisture percentage is become more than 90, it means the water pump will not be triggered. When the moisture percentage is below 90%, and it will trigger the water pump to watering the plants.
I'm Holling. I would like to express my experience working on the IoT-based smart agriculture project. Working on this project was an incredible learning experience. At the start, I was first stressed by the complexity of the IoT-based system and worried about how to connecting the multiple sensor, programming the microcontroller, and visualizing the data. However, with some research and my teammates' assistance, we overcame that difficulty and got the sensor working. I learned a lot from my teammates who are always willing to explain things to me in a way that makes sense. This project has shown me the potential of agriculture with technology. We were able to monitor soil moisture and the light level using sensors and see the data in the cloud. It was amazing to see how this data could be used to make decisions about crop care based on data. Overall, the project was an outstanding educational experience that increased my understanding of IoT-based systems. That's all from me. Thank you.
I am Lao Senjie. I would like to share what I gained the experience in this project. First of all, I gained a lot of knowledge about IoT-based smart agriculture. For example, we use the Arduino ESP8266 as the microcontroller to control the soil moisture sensor and LDL sensor. The soil moisture sensor used for monitoring moisture of plant. If the moisture sensor detected the plant need watering, the water pump will auto watering. Besides that, LDL sensor used for detecting and measuring light level of plant surroundings. Hence, these two sensors can monitor the plant to grow as well. Not only that, I also learned that how the Arduino code work for the sensor and how Arduino interact with ThinkSpeed to implement the cloud-based visualizations. As a result, we can monitor the real-time data visualization via ThinkSpeed. That's all for me.
My name is Yap Wan Yi. Now I will continue to reflect my experience working on this project. Working on the IoT-based Smart Agriculture Real-Time System project was a significant learning experience for me. It allowed me to expand my knowledge in various areas, including agriculture and IoT. I had the opportunity to work alongside my teammates and learn how to effectively collaborate and communicate with them to carry out this project. This project required me to think critically and innovatively to overcome various challenges, including technical requirements and practical considerations. Additionally, I learned the importance of addressing real-world problems and creating solutions that could have a positive impact on the environment and society. Overall, this project provided me with a deeper understanding of the potential of technology to revolutionize the agriculture industry and create a more sustainable and efficient farming system. It was a highly rewarding experience that allowed me to develop new skills and expand my knowledge while working towards a meaningful and impactful goal.
Hi, my name is Najee, and in real-time system, I learn from our projects, Smart Agriculture, learn a lot of the knowledge of the Arduino, the various of components, and as well as our leader, Holy Inks, is lead us three members is very well, and I will also provide a lot of collaborations with all of our members. So this very great experience in this subject's real-time system. Thank you.